And we have, the modern infrastructure, and the curriculum is, really different from all other engineering institutions. Say we follow broad-based education system for nearly 2 decades, that is 20 years of time. And it is the ICFI is a constituent of ICFI Foundation for Higher Education. It's a deemed university, and it is a not-for-profit organization. It will be a surprise to everyone. There is no profit and loss kind of thing. And it is a research-driven university, and we recruit faculty of high standards for all the departments. We recruit faculty either from IITs, NITs, and abroad. The computer science faculty strength is very, very good. We have very good faculty strength with research potential and teaching capabilities. Now, since I have introduced the ICFI Tech, I would like to take this as an opportunity to introduce the panelists and introduce about the program. As I said earlier, ICFI Tech Hyderabad is willing to augment its lab infrastructure, especially the artificial intelligence and data science infrastructure. We have interacted with many of the vendors. I mean, it's not vendors, I mean, the service providers. And the IBM is one of them, and we have interacted them. So we are, thinking of establishing a kind of, the center of excellence, using which all our students of computer science and data science and artificial intelligence and other engineering students can also really see what is really happening with the infrastructure. How do they really, implement their projects, and it will give really the, the industry infrastructure, and they can have the hands-on here itself, so that it will be easy for them when they join the industry to work on, the artificial intelligence and the data science projects. So in a nutshell, there is a plan to have the infrastructure for the data science, and we are in touch with IBM to have open power and open power, the infrastructure. We will be establishing the center of excellence. So this is the crisp introduction, and that is how we are with IBM today. Now, I would like to take 1 or 2 minutes to introduce. 1 or 2 minutes is not sufficient to introduce the panelist, but still, for the want of time, I'll take 1 or 2 minutes to introduce or talk about the panelist. The first panelist is Hedglin from IBM, and the title of the talk would be on the artificial intelligence key features and then use cases. There are so many use cases. So she will be, or the panelist will be highlighting on this. And she will also, the panelist also will demonstrate examples of machine and deep learning models in practice using IBM AI products and tools to cover some of the common starting points and insights along the AI journey. If you are really interested to interact with the panelist, okay, we can provide the LinkedIn link so that you can have a look at it. The panelist is an executive IT architect leading client engagement for the machine learning and deep learning on IBM Power Systems. She works in the IBM Power System Worldwide Client Experience Center, helping clients define and prove out their AI strategy through the enterprise design thinking and prototyping. Her background is a numerical analysis and parallel system, HPC, HPDA optimization with Master of Science degree from Mathematics from Purdue University. She resides in Charlotte, NC. The other panelist is Edison Sai, He is a revenue foresight expertise. His title is AI, the usefulness of customer lifetime value. So the panelist will highlight the customer lifetime values and its advantages. He is a co-founder of Revenue Foresight. He is a financial economist. Actually, it's a lucrative skill set because the fintech is fetching a lot of attention with the artificial intelligence, machine learning, and data science as the subjects. And he is asset management and hedge funds. He is an accomplished technology executive holding senior roles at a variety of startup companies. Even if any of the students are interested to have the startup, he is one of the important person. You can have a contact with him. And the third one is Srinivasan. He is from Quantum Ventura, California. He will be talking about future of technology, and he is a CEO at Quantum Ventura. And this presentation will be on machine learning 2.0, artificial general intelligence. Now you see, we are talking about artificial intelligence. Now it has become artificial general intelligence, smart manufacturing, quantum computing, blockchain, autonomous systems, and AI agents. Srinivasan is a serial entrepreneur with a strong technical and management skills, with a deep seated position for startups. Being a futurist, he is fascinated with trying new cutting-edge technologies at a very early stage. His area are on deep and AI and machine learning, cognitive computing, blockchain, cybersecurity, and quantum computing. So he has extensive background in launching new technologies and product lines across multiple markets. He is a strong believer in user and corporate data privacy, data protection, and data confidentiality. With this small, the brief note, I hand over the session to Mr. Ganesan Narayanasamy, IBM, to kick off the session and make it interesting. Thank you very much, students and panelists and Ganesan. Thank you very much.
Thank you, Dr. Vadivel, for a wonderful introduction, for all the panelists, with a lot of patience. I really appreciate it. And, interest of timing, I'd like to, invite Clarisse Hedglin to start the presentation. This is a great opportunity for you to, get in touch with the worldwide, the leaders of, the AI from IBM and, few other companies too. Clarisse, please go ahead and start your presentation. Thank you.
Okay, let me confirm that you can hear me and see my screen.
Looks very good, Clarisse. Thank you.
Okay, let's get started. Thank you. It's an honor to be among everyone here to talk to you about artificial intelligence. What we're going to cover are some use cases and where AI is being applied and some of the big picture of how AI fits in the enterprise and research. We'll talk about the AI ladder and the life cycle of AI projects. And we'll talk about AI at scale and what it takes to build up an AI infrastructure for your work. So as you know, AI is the fastest growing workload. This was from 2018. Nothing has changed. It's even faster growing than it was a few years ago. A big piece of that is because of some of the breakthroughs in compute power and algorithms relative to deep learning and neural networks that have really brought AI back to the forefront of customer experiences. So when I talk about artificial intelligence, as I mentioned, it's been around for many, many decades. And there was in the early 80s some interest to start using machine learning to augment decision making. And that happened in the 80s, and until the 2010s, it was a piece of the interest, but not very explosive. In the 2010s, we had new algorithms relative to deep learning, especially around vision capabilities, that brought a new interest in using AI. And the CEO of NVIDIA described AI as the automation of automation, which I thought was very interesting take on this, because it is about getting systems to do more and more autonomously with less and less decision making that has to be done manually. So other areas that you'll hear relative to artificial intelligence is reinforcement learning and transfer learning, which are techniques to make the process of building models and developing techniques and algorithms accelerate. So as I mentioned, the idea is to go from data to insights and action from your data. And what AI does is it decreases the amount of human intervention that is needed to get from the data you have to a decision. So in the early days, we had descriptive analytics and decision making. So you basically had human decisions based on what has happened. Then as systems became more sophisticated in decision making, you were able to be predictive. What will happen? Can the data predict what will happen? And even from there, move on to what should we do and have the system make recommendations and decide what to do. The era of cognitive learning is about the system learning on its own and having the final decisions made by human decision making. So the advantage there is that you're accelerating the information that you're getting from your data to get to faster actions with hopefully less error and more repeatability in your analytics predictions. So we see different use cases for artificial intelligence. I'll talk about two dimensions to this. The first is the types of use cases you see, and then the types of AI that you can use to approach them. So the first set of use cases that we see tend to be more the traditional AI that has been going on with machine learning techniques for many years, like regression, logistic regression, things like that. And the data tends to be structured data. So you're looking at rows and columns, and you've got very well-known algorithms to come up with decisions. The second type of use case that we see is more along the use cases where you're basically using deep learning, vision type models, where it doesn't have to be just images, but anything you can transform into a matrix and apply neural networks to. So some of that is magic. When you do the processing, you end up with answers. You're not necessarily doing linear programming for this. You're basically using these deep learning techniques and models. And then the final category of use cases that we see are all the ones that are surrounding natural language processing. And in India, with so many different languages, this is the type of AI that you may need to translate, to go from speech to text, text to speech, to understand language, and to find the right context in your natural language processing in your processes. So this is where chatbots would fit in, where, like I said, translation services, maybe these are the types of AI use cases relative to NLP. Now, when I talked about the type of AI, we talk pretty often about, and this is primarily our IBM research team looks at where we are relative to the adoption of AI. And we talk about narrow AI, which is powerful for very specific tasks, somewhat opaque, so it works, but nobody's really sure how it works. and potentially expensive. So that's narrow AI. So very task focused and obscure and possibly costly. Broad AI is the idea of introducing robustness, transferability, explainability, and scalability to your AI models. And so the idea there is that you can have models that are more transparent, more multifaceted in terms of use cases and applications, and that's what we call broad AI. In the media, you might hear about general AI, and so this is really more the realm of science fiction, where systems, robots take over the world, completely autonomous, fluid reasoning, indistinguishable from human characteristics. That's not happening possibly ever, and certainly we are nowhere in that realm of science fiction scenarios for AI. So the scenarios where AI really can be useful today are vast. We talked about the types of use cases we saw, but in general, any complex system that has more data than can be evaluated by humans with traditional systems and by hand, manually, are a good fit for introducing AI processes and opportunities. Anything relating to personalization and simulating relationships, you see this with chatbots and so on. Those are good AI use cases. And fairly advanced, I would say, at this point, with how to tailor, for example, recommendation engines on sales leads and things like that. The other type of area is automation. So anywhere you can automate, and you can build in a smarter automation with AI support that helps make processes and decisions flow. That's a good idea. Part of that automation might include visual recognition, pattern detection. So being able to recognize things from an AI system to accelerate example. And we'll go through some examples on pattern detection and visual recognition. And then finally, design of experiments, optimization. This is using AI techniques to accelerate getting the right prediction, whether it's finding the fastest path to a set of simulation experiments or general optimization challenges. We see a lot of these, for example, in the financial sector. So in terms of where AI applies, at this point, it's across any market, any field. Today, I'm going to give you some examples relative to life sciences and the automotive autonomous driving scenarios. But you see AI in your daily lives now relative to work recommendation engines, sentiment analysis, chatbots, and across the board, we have AI use cases that are emerging. So taking the example relative to life sciences, the idea is to use AI in such a way that you can bring together all the pieces. So in our scenarios that we've looked at, we have tasks that need to be accomplished at the very high level. In life sciences, those tasks would represent genomics, molecular simulation, visual diagnostics, manufacturing quality inspection of tools, things like that. From there, once you have a task, you would build out applications and models to accelerate and automate those tasks. And you need to orchestrate all those pieces coming together as you build your models. You need to know where your data is, where your models are, how you're going to train and deploy those models. And then you've got a data hub where you need the data to use to train your models. In the health field, as I mentioned, we see a lot of use cases. We've seen a lot of researchers in particular look at AI to accelerate some of the COVID-19 research, which is obviously you know, a huge challenge, and anything that adds value to that is critical. The challenges that remain, though AI is not easy for systems, is data overload, app chaos, the adoption of systems, and how to build environments, and then of course performance and cost anytime you build a new system and process. On the automotive side, the adoption to AI is moving from traditional engineering work, where you had the car design, the supplier, and unit sales, and that was the focus. And you've now used AI to focus on users, user experience, and data-driven decisions on the car. So the automotive industry in general is looking at connected cars, but they're also looking at AI across the board. And they talk about connected, autonomous, shared, and electrification imperatives. And every major automaker, manufacturer has these initiatives in place. So when we talk about how that AI fits in the automotive industry, we've got, I mentioned a little bit about the manufacturing piece, but you'll see also relating to the connected vehicle piece, customer experience, risk and compliance, and their internal IT operations themselves. So they're applying AI across all dimensions of their business, not just the car research element, but the end-to-end business, and looking at intelligent workflows that are predictive, automated, agile, and trusted. So all of this has to come together when thinking about where AI fits in a specific industry or research environment. As I mentioned, it's not magic. It takes a lot of work relative to building the right models for the right use cases, making sure you've got the right data, having the trust in the systems and the results that you get, and being able to document all that, and of course, following privacy and regulatory compliances. So you think of AI, you might think of just the algorithm, but when you look at what it really takes to have adoption of AI, a lot of pieces have to come together. Now, the interesting piece for high performance computing is that there has always been a natural fit between the two. Not to mention that some of the new techniques relative to AI, the deep learning techniques, are basically computations, numerical analysis, linear algebra, number crunching. So we talk a lot about the convergence of high performance computing and AI. The data is coming from so many different sources, including sensors now. The idea is, from all those sensors and all that data, how do you get the insights? For HPC, it's traditionally been analysis and simulations. On the AI front, there's applying AI techniques to replace some of those simulation processes, and in some cases to accelerate those simulation processes. So we see a lot of HPC and AI use cases across many of the industries. So let's talk about a few examples. The first one is medical imaging. In this case, we worked with a couple School of Medicines in the United States, and we're able to train 1,300 MRI images in just under 2 hours. And this is compared to what it would have taken over 40 hours with traditional and more manual-based systems. And the idea here is that you can build a model that that can detect things on these MRI images and provide recommendations to the radiologist, so that they have an initial starting point that is a lot faster than starting from scratch with every new image. So this is one use case for that. A second use case along the imaging side is we worked with a team to detect melanoma, so atypical skin lesions. And the input here was not an MRI. It was, in fact, just a simple edge device, an iPhone, basically, where you took a picture of a melanoma or a skin lesion, and you ran it through a model to tell you whether, you know, the probability of it being benign, atypical, or cancerous. So this was a project that was initially, the first few models could not do better than a human expert. And over time, with more images and more data than a single the dermatologist could look at in a lifetime, we're able to build a model that had very high accuracy and that could accelerate the dermatologist's decision making on whether what next steps to take based on those results. Similar to that, relative to imaging and coming up with faster imaging results, we've worked with universities that have cryogenic electric microscopes, so cryo-EMs. And this is what it does. It generates 5 terabytes on average of image data per day. That amount of data that it can generate is a huge amount of data. And these systems are very, very, very expensive. So if we can process the information coming out of these systems faster, you can get more benefit from your system on that. And what we worked with is at MIT, we have a system, a cluster actually of 64 system nodes and many, many GPUs that were used to run and evaluate these high resolution images in parallel. So this was a way to get the most out of that instrument by doing a lot of processing in parallel and very efficiently. Another example relative to life sciences is doing large-scale simulations. Here, the AI is not used specifically for changing the simulation itself, but it was used to pick what the next best simulation would be to get to the result that you're looking for. So we see this solution with CPUs and GPUs to get to the end result. That this type of simulation is used across the board in drug discovery and to look at virus structures and so on. And again, the AI piece came in to reduce the number of simulations to get to the results that they were looking for. So that's something that allows you to there's 2 techniques. You can do faster simulations with faster hardware, or you can do fewer simulations with smarter choices of what to simulate. And so the AI tools that we've come up with address that second piece. If you do less work, you can get to the results faster. So this is using Bayesian optimization techniques to reduce that. So again, with Bayesian optimization AI techniques, you can get faster results because you're actually doing less work. And it can save a lot of money in terms of end-to-end amounts that it costs, for example, to discover a new drug. All right. So that was some specific use cases on the life sciences side. Specific use cases on the automotive side are include from major car manufacturers. As you can see, we had use cases where the car manual was changed for Mercedes from a hard copy book that nobody ever looks at, that just keeps in the glove compartment, to an app, an interactive app that gave you very quick and instant information about your car and things that you probably should read in the car manual, and building a system, an AI system around that manual. The Volkswagen use case was based on the onboard electronics and system, coming up with recommendations, co-marketing recommendations. If you were driving near a store, you could get a 10% coupon because of basically being having access to this system. So it was they call it contextual connected services. I'll go through a couple more examples, but not through all of them. Honda, for example, improved their customer safety and recall systems so that they could get faster support and faster end results for customers that needed to recall, to have their vehicles recalled and retrofitted to solve specific problems. All right, going back to that simulation example, in Formula One, it's very expensive to do a Formula One design, and we used the Bayesian optimization to change up the parameters of the front part of the car, and looking for how to optimize drag to lift ratio, depending on, you can see the parameters, the changes happening as the parameters are being changed. All this is automated. So for a researcher that's designing a Formula One car, they could launch a set of experiments, have the Bayesian optimization accelerator basically pick what the next task should be based on the previous result. So here, oh, this looks like this might be an area of improvement for the design. Let's submit some more experiments relative to that. So this is, and then the scientists could come back later, look at the results, and then relaunch based on the best result of that set of simulations. We are also seeing AI in a very interesting area. I don't know if anyone has heard about this Mayflower project. This is a project to launch an autonomous ship between Plymouth, UK to Plymouth, Massachusetts. This was supposed to be scheduled around the commemoration of the 400 years of the landing at Plymouth and the start of the US, the people moving across the pond from the UK to what will eventually be the United States, but different challenges have come across this project. So in fact, it has not launched yet. So your have an option to still see this live and in action. The idea is that this ship eventually will be able to monitor the oceans and bring in research information without a captain on board. So as I mentioned, it was supposed to start in the spring of 2021 and set sail. As all real projects, it started, found some things that mechanical things, in fact, not AI related items that made it turn around and come back. So it's ready. It learned from its initial attempt. Think of it as agile development. It learned and it's back in the shop, and it's going to launch again soon once it gets through some of those initial challenges. So what does this have to do with AI and IT? So as I mentioned, there's a captain on board, but it's not a human, it's an AI captain. And that's what's happening at the edge. There's a control center. So this is the on-prem piece of the project. There's a lot of management of the mission happening here, optimization work, and a safety switch, so that if something happens in the ocean, there's a control center on land that is also monitoring what's going on. And then finally, there's a cloud component. And so that cloud component is used by the scientific teams to look at the results that are coming through. It's used as part of the weather decision making for the decisions that are happening at the edge for the ship's decisions and driving. And there's also a public portal that you can all go look at to look at the status of this project and see how it's advancing. So the AI captain itself, this should look very similar to the HPC and AI confluence. You start with a bunch of sensors and information. In this case, we have a number of complex models, not just the deep learning vision models, but there's also rules engines and optimization engines to help evaluate and decide what the best course of action is for the vehicle. And then you have a physical control system that goes from the AI decision-making to the actual physical pieces of robotics that have to work to navigate. The AI system is getting information loaded up with the charts, the navigation charts, and then real-time information, satellite information, as well as weather information to help make all those instantaneous decisions on driving the ship. We see this also on the manufacturing and the automotive side, on how all the pieces come together as a hybrid solution. On the automotive side, we have some examples of different factories that have different AI systems for different stations on their manufacturing line, for example, to look at quality as a car or a product is moving through the line, so quality inspection. There's also a lot of work relative to plant optimization and maintenance of equipment sensors and so on. So a lot of AI systems. The point here is it's not just one thing, it's a lot of different models, a lot of different tools. And then you want to be able to replicate that across a lot of different locations, for example, or different apply to different assembly lines and things like that. And then again, you've got everything coming together where you need resources in the cloud and on premise to do the planning, the training, the coordination of all these AI systems. So the point again is it's not just about the code, it's all the pieces that come together to build your model And even at that point, you've built your model, you've got a good business understanding, and you're ready to go all the way through building the model to evaluating, making sure it's accurate and that you trust it and being able to deploy it. You still need all the pieces to manage your data, your infrastructure to have these systems work in production. So we've introduced the AI ladder. There's a book published by Rob Thomas and Paul Zakopoulos at IBM that's very, very useful and good to understand the big picture. The AI ladder is what we talked about. You collect and organize your data. You then analyze your data, build the right models, evaluate them, and then you infuse them, deploy them across your business processes and your research. So infuse is a different word for deploy, but it's the same idea of getting from data to insights. Our take on this from our IBM view and the open power view is optimize systems to do this and data of every type, regardless of where it lives, so that there's capability of working with multiple systems seamlessly. Lots of different data sources. We talked about sensors. The type of data that you want to be aware of is things like ground truth. So you know this is real, curated, accurate data to build your models and to build your systems with some level of confidence. You can use private data, public data, proprietary data. You can purchase data. There's a lot of different ways to assemble the data that you need for your models, but this is something you need to think about upfront as you're building your AI system. Understanding where your data is important. We talk a lot about metadata, so it's not just the data, it's also understanding facts about your data. Where was it taken? Why, you know, under what context? So you can use metadata to train your models as well, because it offers additional information about additional input to your models. I won't go into too much more on metadata, but that is just an important factor in your data view. In the case of the life sciences examples that we were looking at, this is the type of data that is needed to do some of the projects we talked about. And when we talk about data, we also talk about the data pipeline. And again, data into insights. As you're working through your AI processes, the data is also changing over time and has different role at different times. So when you look at your storage in a storage and data architecture, you need to factor in things like, do I have space for transient storage? Do I have requirements for real-time or near real-time analytics, which would require very fast ingestion of the data? We talked about metadata. Do I need to extract, transform, and load data into data lakes so that my systems have access to that data? How am I saving the data? How am I archiving it? How am I taking new data and updating my models to continuously learn? So this is all part of the data architecture that we usually work with clients on, in addition to their AI architecture. So one example of data taking front and center is with Sidra Medicine. In this case, they've completed hundreds of thousands of tasks with millions of files and directories without experiencing any downtime. And I believe this was a project to map the genome for everyone in the country of Qatar. So very, very, very interesting projects. When we talk about the landscape for this, We talked a little bit about the flow and the process. We talked a little bit about the data and the storage infrastructure that you might need to consider. So there's an AI infrastructure. You also have a software layer above those hardware infrastructure that include AI tools and applications and open source frameworks and the tools that you need to develop your algorithms or implement your algorithms. Open Power is the foundation that is supporting the OpenCE, which is a great tool that allows you to start on power systems with basically TensorFlow and some of the PyTorch, some of the more preferred frameworks loaded up and built up as quick as possible when it takes care of all the prereqs for you. Anaconda is the second piece of that lets you install all these packages that are basically ready to go for you. So we typically, when we work with clients and they're interested in the open power and the power architecture, we always point them to the OpenCE and the Anaconda infrastructure to manage their models and their frameworks and the install of OpenCE. The other thing we talk about pretty often is relative to Onyx. This is a very interesting approach. It basically lets you train with any framework on any platform, and then you can use your models through this Onyx common model format and common runtime. You can deploy your model across many different entities, whether it's servers at the edge and so on. So Onyx is a very nice, I would say, framework and platform agnostic way to mix and match with different projects. So you may have some people developing things with PyTorch and some people developing models with TensorFlow. When you use Onyx, you can basically have all those models running on any platform. We also see containerized approach to developing applications and microservices and running things on potentially a lot of different clouds. So this is outside the scope of an AI discussion, but it's something to keep in mind when you want to deploy things and how you might look at building applications that use your AI and deploying. Same with accuracy is clearly an important inference consideration, but across the board, you want to look at other things to make sure that you've got the right decision points when you're building out your AI system. We're all excited about Power 10 coming along. We have a lot of Power AI activities going on today with the Power 9 and specialized performance accelerators. With Power 10, we will also have a different set of approach on accelerators. We're looking at optimized math instructions inside the architecture itself. And we've got PCI Gen 5 that is basically going to be sufficient for most use cases. So that's the roadmap for Power 10 is out and very interesting. Right now, we see most of the work going on Power 9 and accelerating there. So I will conclude with the last piece of experience when we look at how to build an AI system, and that is considering how to trust your systems. And so you want to be able to make sure as you're building out a system that it's thought out from a fairness perspective, whether you can explain decisions that are coming out of your model with proxy explanations and things like that, K-line techniques. You want to be able to avoid hacks, making sure it's secure, making sure it's robust from an adversarial perspective. We see a lot of techniques around general adversarial networks applied here. And is it accountable and transparent? So with that, I will conclude with a few things on our interest. We have AI research, we have AI users, and we have AI leaders that are all working with IBM. And I want to thank you for your time, and the Open Power Foundation for inviting us to talk.
Thank you very much, Clarisse. Very detailed and wonderful presentation, and thank you very much for the the wonderful the detail. These kind of things definitely help many students, researchers in the world, and what is that we have in our table, as a kind of offering for many customers. And certainly one of them is actually ICFI. They are also interested to collaborate with us on AI, and it's a great opportunity, Clarisse. Thank you. And as audience panelists, any questions for Clarisse? We do have 3 minutes time for question and answers as per the schedule. Yeah, just got an input. Feedback from people like clear, sequential, technically sound presentation, an excellent session, madam. Posting it.
Thank you.
So maybe
students can ask, madam, some questions.
Yeah, it's an opportunity to interact with the worldwide the AI leader, and and also the solution specialist. So students, if you have any questions, please go ahead and post it in the question and answer window.
I see a quick question about quantum neural networks. Our quantum capabilities are out on the cloud. I recommend that you go to the Quantum Experience. We have something called Qiskit that actually has some of the AI tooling that is starting to have a role in using quantum technology. So that's an emerging area, very interesting. There's a couple algorithms and techniques that have been developed to start using quantum computers. It's very early. It's probably not an advantage at this point relative to classical computing, but that advantage is going to come as the quantum systems get more robust and larger. So that is definitely an area where there's opportunity relative to using quantum techniques especially for optimization tool projects.
There is another question, Clarisse, about pipeline. Can you tell what pipeline is exactly?
So I think in this context, when we talk about pipeline, we're talking about workflow. So when you start, what you need to start a project, all the pieces that you need as you go along the project to get to your end result. I think that's the context I used the word pipeline in.
Sure, and there are three more questions on the question and answer window. Can AI be trusted for its algorithm? Wow.
It depends on the input, on the technique, on picking the right techniques, and on interpretation of of the output. So it can be trusted with checks and balances, and some of them have to be human. I don't think I can answer the roadmap for academicians and research community. Ganesh, maybe you can take that offline on some of the
Yes, I will.
programs that are available.
Yeah, I will offline. We will answer that. Maybe, interest of timing, we can answer these questions offline while we move forward with the other presentations. Thank you again, Clarisse. Thank you again.
Thank you
for all your contributions, to this wonderful, the webinar. Thank you, and audience.